Hello everyone, welcome to University Prep Calculus. So I'll be starting off with the function basics, and as we move forward we'll be going into more advanced stuffs like derivatives, application of it, integral, limits. But before we get started onto those, I should go over the function basics because this is the most fundamental thing that you should know. So I'll just quickly review it. These are from some pre-written notes I already had. So I'm just gonna go over it quickly, and once we're done with these, I'll be using a online whiteboard to teach you more advanced stuff to make it more interactive. But for these ones, it should be pretty fundamental. You should learn it from grade 12 calculus or advanced function. So I'll quickly go over it. So let's get started. So what is a function? A function is a rule that assigns to each element x in D exactly one element y is equal to f of x in the set E. So if you have one x, you will have only one f of x, which is equal to y. D is the domain of the function, E is the range of the function. What is domain? Domain is set of all possible x values which will make a function. Range is the difference between lowest and highest values. So we'll look into a few examples. Okay, so is this a function? Yes, because 1 is equal to a, 2 is equal to b, 3 is equal to c. It is a function. So this is the domain, this is the range, because each value of x has only one y, or each input has only one output. That's why it's a function. The second one is a function. We'll check. 1 is equal to a, 2 is equal to a, 3 is equal to b. But still it's a function. Why? For each x there is only one y. Even though it's for 1 and for 2 you have the same value of y, still is the function, because each x is only pointing towards only one y. So each input has only one output. Now we'll look into the third example. Just a second. Okay, so 1 is equal to a, 2 is equal to b, 2 is equal to c, 3 is equal to b. Is it a function? No, it's not a function. Why is that? Because for 2 you can have two different outputs. One is b, one is c. So for each input, if you have two outputs, or for each x if you have two y's, then it's not a function. Another way to represent a function is a vertical line test. So if you draw a vertical line test in the with the graph, along the graph, and if it only intersects at one point, just a second, okay, that means it's a function. So if you look into this vertical line, it's only intersecting here. If you look into this vertical line, it's only intersecting at one point of the graph of the function. So is it a function? Yes. Same here, it's only intersecting at one point, it's only intersecting at one point, only intersecting at one point for all these graphs. So it is a function because the vertical line test rule is, if you draw a vertical line through the function or along the function, it should only intersect at one point to be a function. Now, are these functions? No. Why? Sorry. So you'll have intersecting here, intersecting here. So if you draw the vertical line along the function, you'll have to intersect point. Same here with the circle. So these are not functions. So we'll look into this example. We'll consider this graph. Is the graph represent a function? Yes. Why? If you draw a vertical line across the graph, it only intersects at one point. It is a function. It's only intersecting here, it's a function. If we draw another line, so it's only intersecting there, so it's a function. Now we'll try to find the domain and range. So domain is -3, x is greater than -3, or greater than or equal to -3, smaller than or equal to 6. So -3 to 6, that's the domain of the function, and the range is the max min value. So minimum value we have 2 and max value we have 4. So y is greater than or equal to negative 2 and less than or equal to positive 4. And it asks to find f of 0, f of 2, f of 6, and f of negative 3. From the graph we can read it. So f negative 3 is equal to 2, f of 0 is negative 2, f of 2 is 0, f of 6 is 4. So we found all the values. One thing I would like to add into this is if you have a fill circle, if you look into these circles here, these are all fill circles, which tells you these values are included in the domain of the function. If you have a open circle or clear circle, that means those values are not included in the function. For this particular function, so it's included in the function. That's why we have less, greater than or equal to, less than or equal to, which means negative 3 and positive 6, they are within the domain of the function. If it was just negative 3 greater than x is greater than negative 3, that means anything greater than negative 3 is included in the function, but negative 3 itself is not included in the function. So we'll just draw a line to represent it. So let's say we have a domain from negative 1 to positive 2, and we have 2 is a fill circle and negative 1 is open circle. So what that means, negative is in the domain of the function. And to represent it, we can write negative 1, x is greater than negative 1 and less than or equal to positive 2, because positive 2 is fill circle. Anything greater than negative 1, but negative 1 itself is not included in the function. So I expect you all know all these, so I'm not going to spend a lot of time on those, but just to make clear, because we'll be doing few more graphs and practice, but I'll end it here for this lecture. Thank you very much.